psychological textbooks were saying that the mind and the eye that went with it were similar to the workings of a camera. Camera is a fairly simple object. Light goes in through the lens and the image is then received on the photographic plate. The lens being the eye, the photographic light-sensitive plate, the mind. So I direct this at an object. Light from the object comes towards the camera, goes through the lens and onto the photographic plate when I press the shutter. This is now a permanent record, and if we want to look around the object, we must keep pressing the button. Making such a record can be a rather tedious process, and it doesn't really describe how our minds work. Our minds, in fact, record multi-dimensional image, and they can look around these. They don't have to resort to a series of two-dimensional linear photographs. Let's look again, then, at the photographic process. If I want further information about this, I would have to take off the top and rephotograph. Now our minds can imagine the outside and the inside and all around. If I want to look around this photograph, I just can't do it. And if we have holes in the plate, we get holes in the image. If you cover half your plate, you lose half your image. If you shatter a photographic plate, the image is destroyed. So we've discovered then that cameras are inadequate, totally inadequate, as a description of the way that our minds work. And this is even though they're a fairly recent technological development, within the last 150 years, in fact. So the question then is there anything in our modern technology that can give us a better comparison for what goes on inside our heads? The answer is fortunately yes. Within the last 25 years, we've developed what is known as holography. This is a three-dimensional form of photography, and we have here a simple illustration to explain it. A laser beam is split into two. One half of the beam travels towards the object to be photographed. The beam sprays off it, and some of the rays go towards the photographic plate. The other half of the beam is reflected so that it approaches the photographic plate at a different angle. Now, where this part of the beam and this beam meet at the plate, they interfere with each other so that the waves, the high waves and low waves of the light, interrupt. And we get what is known as an interference pattern. Now that interference pattern is recorded on the plate. And if you take away the plate, it has that interference pattern on it. You can't see it, but it's actually there. If you then take away this part of the beam and the object and put the plate back, this reference beam reproduces out here the original object so that it actually looks like the original. It's a three-dimensional ghost image. So let's have a brief entry into the world of holography. This is a three-dimensional image of the brain. When I take away the solid object, the ghost still remains. Now the three-dimensional ghost there can actually be probed. You can put your finger through it. It's completely in space behind this holographic plate. Another extraordinary feature of these is that if I take out the plate on which the image is contained, I can look through it, you see nothing on it, but the image is in fact contained within this plate in billions and billions and billions of tiny image centers. We can also, in this three-dimensional holography, get perspective, so that if we move, we can actually see around the three-dimensional photograph that we've taken. Now, another extraordinary feature of the hologram is that if we cover up roughly half of the plate, we can actually look around the side of it and still see, or in fact uncover, the images behind. Very similar to looking through a window with a curtain which has been half drawn. Now, there are a number of other extraordinary qualities about these lasers. The image that they project is a three-dimensional ghost. It's absolutely real. You can walk around it, and if you walk around to the back, you see the back. If you look at it from above, you see from above. So they're using these, obviously, in a number of ways. For example, in theatre, the Hamlet scenes where you have a ghost actually becomes a holographic ghost. You can put your hand through it, probe around. It really has all the standard qualities that ghosts are supposed to have. You can get your Cheshire cat smiling at you with no body with a hologram. Now, another thing about these is that if you take your plate and shatter it, and then pick up any one of the particles of that plate, that particle, whichever one it happens to be, will still contain the image, so that each part of the holographic plate contains enough information to reproduce the entire original image. So let's have a look at that by first taking this plate, which has got a holograph of atoms on it, and then we're going to shatter it. Now, if I take one of these pieces and get it at the right angle, it will in fact reproduce that original image. And if we were able to move around more with this particular piece, we would see the whole atom. Now, this is very, very similar to the way that your brain works. Each cell contains whole structures of patterns which are duplicated in other cells. I said that holography was much nearer the truth, but really it's not even the half of it. Your brain is infinitely more complex, more multidimensional, more advanced, more refined. Just think of a familiar object and the myriad ways your mind can play with it.
If you go down in the woods today, you're sure of a big surprise. If you go down in the woods today, you better go in disguise. For every bear that ever there was will gather there for certain, because today's the day the teddy bears have their picnic.
That was some picnic, but now let's get down to some real work. What I want to do is to instill a bit of imagination into those two-dimensional black and white patterns we saw at the beginning. So if we look at the bottom center, words, we could replace it by a hook symbol. And we could add a bit of depth to memory. So our centers now make a more immediate impact. And instead of the word I, we could do a little sketch. You should remember from the I program that we defined reading as the way you interacted with symbols. The first four stages were recognition, registration, comprehension, and integration. Another aspect was perception. Remember we said look for color, shape, size, texture, so we can make the lettering reflect these ideas. Now, the basic idea is becoming clear now, and our two-page notes are taking form. Remember, the right-hand side is for your linear information and graphs. Now, we've seen up to this point that the mind is far more holographic dimensional than we have previously thought. And we know that these patterns have to be in some form a reflection of our mind's internal patterning. So we need some kind of method for taking this more or less off the page. And there are a number of ways of doing this. Firstly, we can use arrows. The arrows connect parts of the pattern which can't be connected on a normal page. Here, for example, we have shape and we've got symbols. So we have an arrow which connects those two parts of the pattern. Now, the arrow, of course, doesn't simply have to be single-headed. We can add other arrows so that the head can become multiply pronged. And also an arrow isn't always one directional. It can have two directions. The information can more or less swing back and forward between itself. So we add here another arrowhead. Now, in addition to arrows, in order to make these things more dimensional, to show that the links are not just on the page, but in a sense beyond the page,